Here you are given the molecular formula of a compound. How do you use this NMR spectra for determining the exact structure of the molecule? For this, first of all, you have to write the constitutional isomers of this molecule by writing its bond line structures first. These are the bond line structures of this molecule, whereby we can write this molecule as straight chain and branched chain molecules. Then we have to know how many protons are present in each of the carbon atom of the chain. For this purpose, we have to write the condensed structure of each of the molecule, such as it is 1 chlorobutane, 2 chlorobutane, 1 chloro 2-methyl propane, 2 chloro 2-methyl propane. Then analyze how many signals are given by each of these proton of carbon atom. In the first case, 1 chlorobutane, you can see this CH2 group is connected to this CH2 group. Thereby, this CH2 group give a triplet, and this CH2 group connected to CH2 groups on either side. Thereby, it will give 5 signals, I mean a quintet as per the n+1 rule. Then the CH2 group connected to a CH3 group and this CH2 group. Then this CH2 group must give a sextet for the protons, and this CH2 groups must give a triplet. But this NMR spectrum indicates only 3 signals, 2 doublet and a multiplet, and hence this molecule is not this structure is not the exact structure of the molecule. Then in the second case, see, it is 2 chlorobutane. This CH3 group gives a doublet because it is attached to this CH group, and this CH group connecting to this CH2 and this CH3. So it should give a sextet as per n+1 rule. There is no sextet in this NMR spectra. So the second structure is not the exact structure of the molecule. And if we see this molecule, the last molecule, that is 2 chloro 2-methyl propane, it gives all these methyl groups are connected to a single carbon atom, and all these 3 groups are identical. There is no adjacent hydrogen or proton in this carbon atom. There is no proton in this carbon atom. Thereby, this methyl groups gives a singlet, but there is no singlet in this spectrum, and hence it is not the structure of this molecule. See, this molecule, this CH2 group is connected to this CH group, and hence this CH2 proton gives a doublet. Here you can see a doublet. This CH2 group is connected to this Cl, electronegative atom. Thereby, its chemical shift is large. So this is the doublet given by this CH2 proton. Then this CH proton is connected to 2 methyl groups and a CH2 groups. So these CH groups give a multiplet. You can see here a multiplet at around 1 ppm. Then you can see this CH3 group and the second CH3 group are connected with this CH group, and hence it gives, there are 6 carbon atom, and so these 2 methyl group altogether gives a doublet, and hence we will get this doublet around 0.9 ppm in the spectra. So the exact structure of the molecule is 1 chloro 2-methyl propane. It is the spectrum of 1 chloro 2-methyl propane. It is the correct structure of the molecule, 1 chloro 2-methyl propane. Now move on to our next example. Which of the isomer gives the following NMR spectra? See, these are the dibromobenzenes, 1,2-dibromobenzene, 1,3-dibromobenzene, and 1,4-dibromobenzene are the constitutional isomers of dibromobenzene. If you take 1,2-dibromobenzene, you can see a plane passing through the benzene ring, which bisects the benzene ring into 2 equivalent halves. So both of these HA protons are equivalent. Similarly, HB protons are also equivalent, and hence only 2 peaks will be obtained for 1,2-dibromobenzene. Here there are 3 peaks, and hence the 1,2-dibromobenzene can be eliminated. And in the next example, it is 1,4-dibromobenzene. Here also a plane passing through the benzene ring, which bisects the benzene ring into 2 equivalent halves. Thereby, all the protons are equivalent. You can see all the protons are equivalent. Only a single peak will be obtained for this 1,4-dibromobenzene, and hence this molecule or this isomer is also eliminated. Then in the last example, it is 1,3-dibromobenzene. Here also a plane passing through the benzene ring, which bisects the benzene ring into two equivalent halves. But this HA having a single peak and this 2HB are equivalent and hence gives another peak, and HC also having another type of proton, or it is not equivalent to HB or HA, and hence a distinct peak is obtained for this HC proton. So we will get three peaks for 1,3-dibromobenzene. Here there are three peaks, and hence this NMR spectra is of 1,3-dibromobenzene. You can see it is the peak of HA proton. HA proton will not split its peak, so it gives a singlet, whereas HB protons gives a doublet, so it is the doublet of HB proton. And HC proton having two equivalent protons, neighboring equivalent protons, thus HC proton gives a triplet, so it is the peak of HC proton, and hence the NMR peak is of 1,3-dibromobenzene. Okay, it is the method of how we can identify the structure of molecule by getting the proton NMR spectrum.